Alright guys, here's your help video for AP practice test number 3. Number 1, the region enclosed by the graphs of y equals x squared and y equals 2x is the base of a solid. For the solid, each cross-section perpendicular to the y-axis is a rectangle whose height is 3 times its base in the xy plane. Which of the following is the volume of the solid? So a lot of these expressions are pretty similar here. One narrowing factor that we could look at is this. It says perpendicular to the y-axis. And when that happens, we know it has to be a dy expression. So we're going to go ahead and ignore those. So there's one thing. Now, if it was perpendicular to the x-axis, we'd be looking at these ones over here. The next thing is that the base is going to be the function to the right minus the function on the left. So it's going to be minus. But let's go ahead and work these out a little bit just to be sure. So first of all, for this function here, if we're doing it with respect to y, we want to get the x by itself. So I would square root both sides. And for this one, I would divide both sides by a -2. All right. So now we would do the function on the right minus the function on the left. Now, it doesn't really matter which one's on the right and left because I can tell. They're putting this one first on both options. So I know this one has to come first. So it's right minus left. And the double negatives here will become positive. So we're going to be picking option B in this case. Okay. You got to watch out for some key things on this problem is, are you perpendicular to the x-axis or the y-axis? And this negative here will make a difference as well. Let's go ahead and move on to the next one. So for this problem, they're telling us the average value of the function on the interval from -2 to 4 is 12. And so when we see that right away, we want to think of this here. All right. And in other words, this one here is just going to be 1/6. And they tell us that that average value is 12. Now what I'm going to do is I'm going to multiply both sides by 6 just to get this integral by itself. So the integral of f of x is 72. Okay? Now their question here, and I left these numbers out. I should have these on there. Let me put those on there right now. Okay. They want us to figure out what's this. Well, that's the same thing as this. Property of integrals that we can apply there. And we just found out that the integral of f of x is 72. So this is 1/4 times 72. And 1/4 of 72 is 18. So our answer would be D for that one. All right, let's take a look at number 3. So number 3, we've got this graph of these two functions, f of x and g of x. They tell me that h is equal to f over g, and they want to know what's h prime of 2. So the first thing we need to do is find out what h prime is. H prime is going to be low d high minus high d low. Draw a line, square below. And then we want to go ahead and plug 2 into that. So it's going to be g of 2, f prime of 2, f of 2, g prime of 2, all over g of 2 squared. Now, it's an important thing to understand that when you have a derivative, like g prime or f prime, those are slopes. And when you have g or f, those are y values. And the number we're plugging in is the x value. So we're plugging in x equals 2, which means we're at this spot on the f function and we're at this spot on the g function. Now, let's go ahead and plug these in. First of all, I'll start off with g of 2. Well, that's the y value of the g function at x equals 2, which is 1. Next, we're going to do f prime of 2. Now, that's the slope of the f function at x equals 2. And the slope of this line is a run of 2 and a rise of 1. So that's 1/2. Next, we have f of 2. f of 2 is the y value of the f function at x equals 2, and that y value is 3. G prime of 2, that's the slope of the g function at x equals 2, and that slope is down 2 over 1, so it's a slope of negative 2. And then finally we have g of 2, which is, we've already found that earlier, that was 1, and it's being squared. So we can kind of ignore the bottom since it just equals 1. 1 squared is 1, and when you have a fraction with 1 on the bottom, it doesn't really matter, right? And so here's what I'm left with. I'm left with 1 times a half, which is a half, plus 6. And 6 plus a half is going to equal 13 halves. Okay? Go ahead and move on to the next one. All right. So first of all, I'm going to go ahead and separate the limit here. I'm going to apply the limit to the first term. And then I'm going to apply the limit to the second term. That's just a property of limits. Anytime you're finding the limit of a function with two pieces being added together, you could find the limit of each one separately. Now, anytime you've got a constant like that, the limit at infinity is just 3. For this guy here, though, we end up with infinity over infinity. When you plug in the top there, you get infinity. When you plug it into the bottom there, you get infinity. So when you have infinity over infinity, you get L'Hopital's rule. So we're going to apply L'Hopital to this thing. The derivative of the top is 1, and the derivative of the bottom is e to the x. So plugging that in, we have 1 over infinity. 1 over infinity equals 0, and so 0 plus 3 is 3. Okay? And so that is for number 4. Let's go ahead and move on to the next one. All right, so here they're telling us that we have a graph of f prime. So this is the graph of a slope function, or the derivative function of f. Okay, so this is the graph of f prime. Which of the following statements is true? Well, notice they're asking about whether it's continuous, decreasing, and concavity. All right, so let's think about that a little bit. All right, well, if f prime is continuous, that means that f is differentiable. And if f is differentiable, then f is continuous. Okay, now as you guys can see, this is the graph of f prime. There's no holes, gaps, or jumps. So f prime is continuous, therefore f must be continuous. So 1 is true. Let's go ahead and check out the other statement now. Is it decreasing? Well, if f prime is less than 0, now that means in this case below the x-axis, then f is decreasing. Now, contrary-wise, if f prime is positive or above the x-axis, that means f is increasing. But since they're asking about decreasing here, is this graph always below the x-axis from A to B? No, it's not. So this is actually a false statement. So we have number 1 is true, but number 2 is false. Let's go ahead and take a look at number 3. On number 3, it says we're talking about the concavity of f. So if f is concave down, that means that f double prime is negative. And if f double prime is negative, that means that f prime is decreasing. So on this graph, does this graph of f prime look like it's decreasing, or does it look like it's increasing? Well, it looks to me like f prime is actually increasing. It's getting higher and higher and higher. So this is also false. So in this case, we have these two are false, this one is true, and therefore the answer to this one is A. All right, so that is the answer to number 5. Let's go ahead and move on to number 6. All right, an isosceles right triangle with legs of length S. So I'm going to go ahead and draw that. Has an area of 1/2 S squared. At the instant when S equals 8 centimeters, the area of the triangle is increasing at a rate of 16 square centimeters per second. So dA dt, the rate of change of the area, is increasing, which means it's a positive 16 square centimeters per second. What at what rate is the length of the hypotenuse changing? So that we want to know what is dh dt at that instant. So this is a related rate question. Step 1 is to draw a picture. Step 2 is to identify what rate you're given. And step 3 is to identify what rate you want to find, which we've already done. Now step 4 is to find a formula that will connect the area with the hypotenuse. Now they've given us a formula up here. The area is equal to 1/2 s squared, but the problem with this formula is that it connects a to s. But for this step, I need a formula that connects a to h. And sometimes they'll give us problems like that. So what that means I need to do is I need to somehow get rid of this s and replace it with an h. How can I do that? Well, coming back over here, here's my hypotenuse, right? There's my h. I know that s squared plus s squared equals h squared, which means that 2s squared is equal to h squared, which means that s squared is equal to h squared over 2, if you just divide both sides by 2. So since s squared is equal to h squared over 2, I can actually rewrite this formula, and I can replace my s squared with h squared over 2. So now I've rewritten my formula so that I've got my formula having an a and an h, which connects the two variables that I care about. Now I'm going to simplify this formula a little bit. I'm going to multiply 1/2 times 1/2, and I'm going to make that 1/4 h squared. And then from there, we're going to go ahead and move on to the next step. Now the next step is to take the derivative. All right, so let's go ahead and do that. So step 5 is to take the derivative of my function. So if I take the derivative of this, I'm going to end up with dA, call that step 5, dA dt is equal to, I would multiply the 2 to the front, which is going to be 2/4, which is 1/2 h, and then times dH dt. Okay, so that's step 5, is to take your derivative. Step 6 is to go ahead and start plugging in anything that you can. Now, for instance, I know what dA dt is. That's 16, so I can plug that in for dA dt. I have 1/2. That's just going to stay there. I don't know what my hypotenuse is, but I'm about ready to figure that out. And I don't know what dH dt is, and that's because that's the main thing I'm trying to find anyway. So before I can find the main thing I want to find, I need to find out what h is. Well, they told me something important here. They told me that s is equal to square root of 8, right? So earlier we found out that s squared is equal to h squared over 2, right? Well, they're telling me that s is equal to the square root of 8. So I'm going to go ahead and replace s with the square root of 8. Now, whenever you square the square root of 8, you're just going to get 8. So now I can solve for h, which is what I'm trying to find here. So I multiply both sides by 2, and I'm going to get 16 equals h squared. And if I take the square root on both sides, I get 4. And so I'm pretty darn close to the end here. All I have to do is solve this. So first of all, what's 1/2 times 4? Half of 4 is 2. So let's go ahead and replace that. And then divide both sides by 2. And let's see what we get. If I divide both sides by 2, I'm going to end up getting 8. So my final answer there will be 8. So if I divide that by 2, I get 1 there. Divide that by 2, I get 8. So dH dt is equal to 8. So step 1, draw a picture. Step 2, identify the given rate. Step 3, identify the rate you want. Step 4, create a formula that connects the variables you care about. Step 5, take the derivative of that formula. Step 6, plug in everything you possibly can, and then solve for the one thing you're looking for. Let's go ahead and move on to number 7. All right, so the graph of which of the following functions has exactly one horizontal asymptote and one vertical asymptote. So the way that you find a horizontal asymptote is by finding the limit at infinity and also from negative infinity. Now, if these both come out to be the same answer, that means there's only one horizontal asymptote. To find where the vertical asymptotes are, you just set the denominator equal to 0. So for this problem, the answer is B. So I'll just tell you that in advance. And what you're going to do to make sure this is just do exactly what I just said. So the first thing I'm going to do is I'm going to find the limit as x approaches infinity. Now, when you're actually doing your retake test, you're going to have to do it on each one to find out which one works. Now, if I do this, I end up with 1 over infinity plus 1, which is 1 over infinity, which is 0. Now, if I go ahead and plug in negative infinity instead, if I find the limit at negative infinity, I end up with negative infinity plus 1, which is 1 over negative infinity, which is still 0. So I have one horizontal asymptote, and that horizontal asymptote is 0. Now we got to find out where is the vertical asymptote. The vertical asymptote can be found by setting the denominator equal to 0 and solving. If you get one answer, then that means there's 1. If you get 2 answers, that means there's 2. If you don't get any answers, that means there is no vertical asymptote. So I'm going to do x cubed plus 1 equals 0. I'm going to subtract 1 on both sides. And then I'm going to take the cube root, and I end up with one answer. And it's negative 1. So that is the reason why it's B. So to find the horizontal asymptotes, you find the limits from the left and right. To find the vertical asymptotes, you just set the denominator equal to 0. Go ahead and move on to the next. For number 8, we're being asked to compare the slopes at these 3 points. Okay, so as you guys can see, at negative 2, we have a 0 slope. At 0, we have a positive slope. And at 3, we have a very steep negative slope. So 3 will be the smallest one. 0 will be the biggest one. And when I say 0, I mean x equals 0. These are x values. And at negative 2, these are, we will have a slope of 0 because this is a negative slope. This one gives me a 0 slope, and this one gives me a positive slope. So we're looking for the option that goes 3, negative 2, 0, and that would be option C in this case. Go ahead and take a look at number 9. So anytime they give you an antiderivative and 2 y values, well, I'm sorry, this is actually the h is the antiderivative of this. Basically, the way we're going to set this up is we're going to say the integral of this function here is going to be from 1 to 4. Now, where's that 1 and 4 coming from? That's coming from these x values. That's going to be equal to h of 4 minus h of 1. So what I'm going to do is I'm going to punch this into my calculator and solve it. And I already know h of 4 is 10. And then after that, I just need to find h of 1. So basically, take your number here. You're going to minus it by 10 and then divide by a negative 1, and you'll find your answer. Okay, but I'll let you guys go ahead and handle that. Let's go ahead and move on to the next one. So the continuous function f is positive. So now let's think about that. I want to draw a picture of this. We have a continuous function. It's got no holes, gaps, or jumps in it. So it's continuous. It's positive. It's also, so that means it's above the x-axis. So I know that f is always up here somewhere above the x-axis, and it has a domain for x is greater than 0. So that means it can't ever cross this line. So I've got a function that is always in this quadrant. It's always above the x-axis and to the right of this line, and it's continuous. There's no holes, gaps, or jumps. So I don't know what that could look like. That could look like a few things, but let's go ahead and draw that. Which one of these statements could be true? Well, in this case, the answer is C. Why is that? Because as x approaches 0 from the right, it can't ever reach 0, so it's got to shoot up into infinity. So the limit from the right would have to be 0. Whereas for this case over here, as x goes to the right forever, which is what this means, we're moving to the right, it's reaching some positive number. It has to be a positive number because it's always above the x-axis, so that makes sense as well. So in this case, C would be the answer. Go ahead and move on to our FRQs. Okay, so for FRQ number 1, we're not using a calculator. This table has x values and the f prime values that go with each of those x values. They give us an initial condition here. F of 0 is equal to 30. That'll come in handy. They tell me the first derivative of f is always somewhere between 0 and 8. Let's see. It tells us this has got a continuous second derivative, and that just means that this function is differentiable. It has a continuous second derivative. So we'll keep all that in mind as we go ahead and progress through finding the solutions to these problems. So it says use a midpoint Riemann sum with 3 subintervals of equal length indicated by the data in the table to approximate the value of f of 6. So if I wanted to do equal length intervals, I need to do 6 minus 0, divide the entire interval up into, or find out the total length of the interval, and divide by how many intervals you want. And that means we're going to be going by 2s. So from 0 to 2, and then from 2 to 4, and then from 4 to 6, giving us base lengths of 2. And when you do a midpoint sum, basically you just want to use this middle number in between each pair. And so it's going to be 2 times 3, which is 6, plus 2 times 1, which is 2, plus 2 times 6, which is 12. And that all together is going to give me 20. And that's where a lot of you guys stopped. But that actually tells me the area under the curve from 0 to 6 of this particular function here. Okay, so this is not answering the question, but this is something we have to do to get the answer. The question is actually asking us to find out what is f of 6. So let's go ahead and find out what f of 6 is. Well, another way to think of this integral here from 0 to 6 is to realize that if you integrate f prime, you get f, and then you're going to do 6 minus 0. And we just found out that this integral here is equal to 20 approximately. We know from the given information that f of 0 is equal to 30. So if I just add 30 on both sides, I'm going to end up with the fact that f of 6 is equal to 50. Now that's the final answer. All right, let's go on to the next one. All right, so part B, this one's a pretty tricky question. Let's see. We just found out on part 1 that f of 6 is equal to 30, which is f of 0, added to the integral from 0 to 6 of f prime, right? So let's keep that in mind. Now, in the beginning of the problem, they told us that f prime of 6 is always less than or equal to 8. So they told us this actually in the beginning. So the derivative is always somewhere between 0 and 8. So what I'm going to be doing is I'm going to be gradually turning this into this. And as I do, I'm going to be affecting the 0 and 8 as I go. So for instance, instead of just f prime, I want an integral of f prime, right? Which is fine. I can do that so long as I take the integral of everything else in this inequality. Now, we have a property for this. It's going to be 8 multiplied by 6 minus 0, which is 48. Supposed to be a 0 there. And 0 times 6 minus 0 is just going to be 0, so that's not changing. Next, I'm going to add 30 to everything. Why am I adding 30 to everything? I'll show you in a second. But 0 plus 30 is 30. 30 plus the integral from 0 to 6 of f prime. And then 30 plus 48 is 78. Now, why did I change all this stuff in the middle here? Why did I change f prime to be an integral of f prime plus 30? Well, because that integral of f prime plus 30 is f of 6, right? So that means now I can just replace this middle piece with f of 6 because that's what f of 6 is equal to. And as you guys can see, that means that f of 6 would have to be somewhere between 30 and 78. So the question is, can the value of f of 6 be 78? No, it has to be somewhere between 30 and 78. Okay, so the answer is no, but of course, most of the points are in the work that you show. Okay, so let's go ahead and move on to part C. Now for this one, I'm going to integrate f double prime, and I'm going to get f prime. And then we're going to go ahead and plug in 5. And then we're going to plug in 1 and subtract those two things. So to answer this question, I just need to look at my table. F of 5, I'm going to make this so I can see it. F of 5 is 6, so let's go ahead and write that. Or f prime of 5. And f prime of 1 is 3, and so for this one, the answer is 3. Let's go ahead and move on to the next one, part D. All right, find the limit of this function. All right, so we're going to plug in 0. We're going to plug in 0. And we're going to plug in 0. The first thing you do anytime you take a limit is always just try direct substitution. Now we know from the beginning that f of 0 is 30. We know that e to the 0 is 1. And 1 times 30 is 30, so that's 30. On the bottom, this is 30 times 0.5, which is 15. And 15 minus 15 is 0 over 0. And what do you know? We've got L'Hopital. So we're going to go ahead and do L'Hopital again here. So it's going to be the limit as x approaches 0. Let's take the derivative of the top. That's going to be f prime minus 30e to the x. And then 0.5 times f prime. And the 15 is just going to go away because it's a constant. And then we're going to go ahead and plug these things in again. So now I need to find out what is f prime of 0 minus 30 times e to the 0 over 0.5 times f prime of 0. So let's go take a peek at our table up here real quick. At 0, f prime is 4.5. So I'm going to replace f prime here of 0 with 4.5. This is just going to be 30 again. And 0.5 times 4.5, that's going to be what? 2.25. And I think I'm going to go ahead and avoid just having to simplify that and leave it just like that, because that's good enough. Right? Go ahead and move on to the next FRQ. Now this one is a calculator permitted FRQ, so we want to remember that. All right, let's go ahead and take a look at this. So from 0 to 6 seconds, a screensaver on a computer screen shows two circles that start out as dots and they start expanding outwards. So you kind of have to imagine they start off as dots and then they get bigger and then bigger and then bigger and then bigger. They'll probably eventually cross. So that's the idea there. All right. So at the instant when the first circle has a radius of 12 centimeters, the radius is increasing at a rate of 5/2 centimeters per second. Find the rate at which the area of the circle is changing at that instant. Indicate the units of measure. So once again, we're dealing here with a related rate question. So of course, we're dealing with circles, and it has a radius, and it's got a changing radius. Now they tell me that the radius is changing at a rate of 5/2 of a centimeter per second. That's the given rate. They want me to find the rate of change of the area. So I need to find a formula that will connect radius with area. And when it comes to circles, that's pretty easy. This is, I need to be numbering my steps. This is 1, this is 2, this is 3, and this is actually step 4. So we need to find our area, which is area equals pi r squared. And luckily, that formula connects the two variables exactly as they need to be connected. So we find the derivative of the function. So that's the derivative of a with respect to t is equal to 2 pi r dr dt. And once again, all we got to do is plug in the stuff that they give us. So for instance, I know that dr dt is 5/2. They tell us that. They tell me the radius is 12. And then we just need to put the 2 in there. And there's your dA dt. Did they ask for the units here? Let's see. Find the rate of, indicate the units of measure. Yes. So we're finding the rate of change of area, and we're dealing with centimeters and seconds here. So area is going to be in square centimeters because it's area. And it's per second since we're doing this over time. So you could simplify this if you wanted to. I'm just going to leave it like this, though, but you could simplify it. All right, let's go ahead and move on to part B here. The radius of the first circle is modeled by this. So this is an equation that tells you the radius of the first circle. Now, on the time period from 0 to 6, WT is measured in centimeters, and T is measured in seconds. At what time T is the radius of the circle increasing at a rate of 7 centimeters per second? In other words, if W of T tells you how big the radius is, then W prime tells you how fast it's changing. And they want to know, when does that derivative equal 7? So the first thing I need to do is find the derivative of this function up here. This first 15 is just going to go away. This second 15 is going to get multiplied by this negative 0.6. And then the e function stays the same as always when you take a derivative. Okay, so what is 0.6 of negative? We have 9 there. All right, next I would divide both sides by 9. The next thing I would do is I'd take ln on both sides. And the reason I would do that is because ln cancels out the e. So now I've got ln of 7/9 is equal to negative 0.6t. And the last thing I need to do is just divide both sides by that 0.6, which honestly, I'm just going to write it like that. This is a calculator-based question, so if I wanted to, I can get my calculator out now and turn this into a solid number, but I'm just going to leave it like that because I can. There's no reason why I can't. All right, let's go ahead and let's take a look at part C. All right, a model for the radius of the second circle is given by the function f on the interval from 0 to 6, where f of t is measured in centimeters and t is measured in seconds. The rate of change of the radius of the second circle is given by this. So this is how fast the second circle is changing. Based on this model, how many centimeters does the radius of the second circle increase from 0 to 3? So basically what they want to know is how big is the radius at 3, and how big is the radius at 0, and what's the difference between those? And that will be the change in the amount of the size of the circle, also known as net change. Well, there's another way we could write this. That could be written as f prime from 0 to 3, the integral of f prime from 0 to 3. Now, since this is a calculator-based question, basically I could just do this on my calculator. So we would type this into our calculator. You could also do it by hand. I wouldn't advise that because you can use a calculator, so just go ahead and do it. But anyway, type that into your calculator and see what you get, and that would be your answer. Okay? And that'll do it. So hopefully that was helpful. We'll see you guys later.